f of x alpha. I have a function f of x alpha. Now I make a transformation of the coordinates. So I will get f of x prime alpha. Transformation quantities, I get f of x prime alpha. Now, if I ask what is the gradient of f, gradient of f is defined as dou f by dou x alpha. Okay, let me first ask this question. Just like we asked the differential of x, we ask what is differential of f. Differential of f can be written as del f dot dx. Okay. Why? This is because this can be written as dou f by dou x alpha to dx alpha. Okay, sum over alpha. This is equal to dou f by dou x alpha into dx alpha. Also, you can say that df will also be equal to dou f by dou x prime of beta into dx prime of beta. If you make a change of coordinates, you can actually write it in this fashion. Now you can ask what is dou f by dou x prime beta. Dou x by dou x prime beta, you can write it as dou f by dou x alpha into dou x alpha by dou x prime beta. Alpha is summed over. Correct? Alpha is summed over. Sum over alpha. So if you can see that dou by dou x prime is dou by, you have to write in terms of dou by dou x prime coordinates in terms of unprimed coordinates. This is the matrix that will, so this can be written as sum over alpha. Okay, so sum L alpha beta of dou by dou x alpha df. What is the difference between this transformation matrix and the previous transformation matrix? Previous transformation matrix, remember, dx prime of beta is written as sum over alpha dou x prime of beta divided by dou x alpha into dx alpha. So this is the transformation matrix. Whereas dou by dou x prime beta is equal to sum over alpha dou x alpha by dou x prime beta into dou by dou x alpha. So you can see this difference, this and this. Okay? So this transformation is different. You can see two things here immediately. When I write like this, if I have to write a sum, I must write this as dou alpha into dx alpha. Dou alpha f into dx alpha. Why? in order to get a scalar here, this is a scalar and this is a vector. This is a vector. So this has to be a one form. You understand? The derivative has to be a one form. And hence, the transformation of the derivative, since derivative has to be a one form, it should be its component should be covariant components. Okay? Its component should be covariant components. And since it's a covariant component, it will have a different transformation compared to this. So in the books they say that any vector that transforms like the gradient is a covariant vector. But essentially, more fundamentally, gradient operator is a covariant vector. Because the gradient operator dot this one, the combination of gradient operator and this one should give you a scalar. Okay? So, I am trying to make contact with what is written in the books. Finally, after discussing these fundamental issues, that with respect to transformation, any quantity that transforms like displacement is called a contravariant vector. That is because displacement vector is a vector. Anything that transforms like gradient operator is called covariant vector because that is a one form.
So in this equation you have determined that del f by del alpha, you have put alpha as a subscript.
So all are superscripts. Yeah, all are superscripts at this moment. So is this clear? So these indices are the ones which are usually a little bit confusing, and we can finally say that